Okay, so in section 4.4, you're just going to compare different features of two different quadratic functions. So it really depends on what they're asking, what you look for. So let's look at our example 1. It says Timmy wants to compare this function, which is negative x squared plus 6x minus 2, to the function graph below to see which one has a larger maximum. So I'm going to let the graph be g. And our equation is f. So which function has a larger maximum? So remember, maximum means y value. So which one has the highest y value? Well, let's look at our graph. So max of g. So if we look at our graph, our highest y value is right here, which is at 6. Okay? And we need to find the maximum of our equation. So because that's at the vertex, we need to find the vertex of our equation, which is negative 1 x squared plus 6x minus 2. So this would be in standard form. So we're going to use our vertex is the opposite of b divided by 2a. So we've got a, b, c. So x equals the opposite of b, 2 times a. So 6 divided by negative 2, if you're using a calculator, put that in parentheses, and we get 3. So to find the y value, remember, we substitute x in for 3. So 3 squared plus 6 times 3 minus 2 into the equation. So type all of that straight in, and we get negative 9 plus 18 minus 2, so y equals 7. So the maximum of our equation is 7. So which one has a larger maximum? We can say f. Okay? All right, so let's try the next one. So example 2, we've got the path of a football given by this equation and then a table. So I'm just going to go ahead and plot this table, which I'll let the table be G again. It says which football went higher. So we want to know the y value, okay? Because y is the height. So if I got 0, 0, I've got 1, 10, 2, 40, 3, 90, then 4, 40, and 5, 10. So it looks like this. And we can only use the information based on a table. So the highest it looks like is 90. Okay? So I need to find the highest of the equation, which kind of like maximum and minimum, we want the vertex. So the vertex of our equation well, that's in standard form again. So x equals the opposite of b over 2 times a. So the opposite of b, 2 times a is negative 0.1. So we get negative 6 over negative 0.2. And that's negative 6. You're going to type that in. I just don't have a calculator. So negative 260 is 30. So then to find the y value, remember we plug in x. All right, and I'm going to go ahead and open up so we get negative 0.1 parenthesis 30 squared plus 6 times 30 plus 2 plus 6 times 30 plus 2 is 92. So the equation went higher. Only by 2 though. All right. our last example, they give us two functions this time, and it says which function has the smallest y value. So we're going to find the vertex since this opens up since a is positive, and this opens up since a is positive. So negative b over 2a for both. And I'm just going to put a line right down the middle. So on our first equation, we get the opposite of b over 2 times a, which is negative 1.5. And then we'll go ahead and type that in. So negative 1.5, use a parenthesis since it's negative. So parenthesis negative 1.5 plus 3, and then plus 2. Negative 0.25. Okay, and then the opposite of b over 2 times a, so negative 6, oops, clear. Okay, so negative 1.5. So 2 negative 1.5 squared plus 6 times negative 1.5 plus 10. Not sure. So let's go ahead. We've got 2 negative 1.5. That was a 6. Yep, 6 and then plus 10. 6 negative 1.5 plus 10. 5.5. So they want to know which has the smallest y value. So we're going to circle this one. Okay. If I wanted to know when, then it would be the x value. Okay, so you need to figure out if you want the x value or the y value. If you want the max or the min, you usually want to know the y value. And if you want to know where or when, then it's going to be the x value that you're looking for.